our next packet of notes. This one is titled Histograms Ogives, Dot Plots, oh my. Um, the original intention of these notes is like I actually walk through students how to make all these graphs by hand, more as a hey, you should probably know how to make these in the future. For the sake that I'm sick and not there with you, the creation of these graphs isn't really super important. I feel like as far as graphs are concerned, the only two I've ever seen students on an AP exam, the only two that students have ever made on an AP exam is a stem and leaf plot or a box and whisker plot, are the only two that I've ever seen students make. So for the sake of shortening this video as much as possible, I don't think you need to stress too much on the creation of the graphs part. What you should really be stressing about is how to read the graphs. So I'll kind of quickly talk through how the graphs are created. Whatever, really focus on reading them, and I'm going to show you how to do that in this video. I don't know if I'll get this done in 1 or 2 videos. It kind of depends on how long I talk, so we'll see. So a histogram is a pretty popular one. It is not a bar graph. It looks like a bar graph, but it is not a bar graph. Bar graphs represent categories, qualitative data. A histogram represents quantitative data. So how this works is you need to break the data into intervals. Break the data into intervals. So these are called classes. These are called classes. The intervals called classes. You got to be careful with how many classes you make. If you make too few, you're going to have very tall bars, and you're not going to be able to see shape. If you have way too many classes, you break down the data into tons and tons of groups, your data is going to be flat. You're not really going to see the shape. So you have to find that balance, and it kind of depends on what sort of data you get. So you're going to break the data into classes first. After you do that, and you feel like the amount of classes you have is a little bit more appropriate for the data, you're going to count the number of data points in a class, and that is called a frequency, which is a very common vocab word. It's the frequency. So how many data points show up in that class? Then you're going to graph your frequencies as bars. Okay. If you didn't get all that, pause me, copy it down. So down here on the bottom is an example. I'm going to try and see how much I can fit. That says approximately there. This example is an agility test. You might be familiar with it, where you beeps and you see how many lines you can cross. I don't know, something like that. An agility test. If you want to pause me and write all of this down, go for it. Okay, pause me, write all this down, and then I'll talk through it. So the first thing I did, and when I do this live in class, this is always an interesting part, is figuring out how to break up the classes, because I usually let kids throw out answers. And with this data set, people are like, oh, count by 5. So like do 10 to 14, 15 to 19, etc. And we find out we have too few classes. So it takes a little bit of practice figuring out how to break up the classes. I broke them up into groups of 4. So groups of 3, 10, 11, and 12 are together in a class, 13 through 15, 16 through 18. You get the point. So I made my classes first, and then I went back to my data up above, and I counted the frequencies. So how many data points do I have in 10 to 12? Well, I just have 1. How many data points do I have in 13 to 15? I just have 0. 16 to 18, 4 data points there, so on and so forth. After that, you're making what is very similar to a bar graph, super similar to a bar graph, but we're representing the bottom as our quantitative data. So this is the agility scores is across the bottom, is the different labels here, and my frequencies across the top. So 10 to 12, I made a bar up to 1. 13 to 15, no bar. 16 to 18, bar up to 4, 4, 9. You get the point. Made my histogram. Okay, that's making it whatever. There it is. What's important is being able to read these graphs. Okay, so I'm gonna pretend we don't have this raw data up here, because typically with a histogram, you're only given this. And I just want to talk about some things you get here and some things that are hidden here. Okay, so I went through when I'm doing shape, outlier, center, spread. Starting with shape. Shape's usually pretty easy to see on a histogram. Remember, you're going to say whatever you feel most confident in is a good one. Say what you're confident in, say it, and get out. So with this one, I see a giant hump of data right here. So I was really, really comfortable with unimodal here. Unimodal making me really comfortable. Over here, there is a gap in the 13 to 15. I could have called that out too if I wanted to. So if I was like, I'm not convinced on unimodal, could have called out the gap. With histograms, you can see skewness pretty easy. You're going to see stacked bars on one side, and then it flattens out on the other. So this would be skewed right, skewed left, or roughly symmetric. You could see uniform as well. So you can see all the different shapes very, very easily with histograms. So with this one, I said the distribution of agility scores is unimodal. Great. Context, there's my shape. I said with a potential outlier at a score of 10 to 12. And this is very, very important for me to emphasize here, the 10 to 12. If I'm ignoring the fact that I know the raw data, so let's slide that back like I don't know the raw data. With this sort of histogram, and it kind of depends on which type of histogram you get, I know the amount of data here. I don't know the specific data though. So if I'm going to call this an outlier because there's a gap and he's just kind of sitting over here, I don't know if that outlier is a 10, it's an 11, or it's a 12. I just know it's in this 10 to 12 class. So I just use all that I know, which is I have a potential outlier to score of 10 to 12. That's all I can work with. Okay. So there's that, the median, and I want to go back to this. I've talked about this in class. We could find the location of the median by doing n plus 1 divided by 2. So take the total number of data points that you got, add 1 to it, and divide by 2. So it looks like I have 1, 5, 9, 18, that's 23, 25 data points. So 25 data points plus 1 is 26. 26 divided by 2 is 13. So wherever that 13th data point in line, that's where my median is at. So if you're only given the histogram, what I sometimes do is I kind of mark on it and say, hey, this had a frequency of 1. This is 4, 4, 9, 5, 2. And then I just start counting till I hit that 13th data point, which was the middle. So there's 1. There's another 4, which gets me up to 5. Another 4 that gets me up to 9. I'm going to hit that 13th data point in this bar, okay, in this piece of my histogram. So I know my median is in this category because I don't know the specific numbers. The median is 22 to 24 lines crossed. 22 to 24 lines crossed with a range. So remember, range is the highest number minus the lowest number, okay? I don't know specifics on what the data points are in here. So the range, I slapped this word approximately in there because I just was not sure. So the range there, the highest possible number we could get is 30. The lowest possible number we can get is 10. 30 minus 10 being 20. So 20 lines crossed because I don't have specific figures. Okay. So that is a histogram. Histogram's kind of a big one that shows up pretty often. You got to be careful. Sometimes you know the amount of data, but you don't get the specific data values. So like sometimes mean is out of the question. With this setup, I wouldn't know the mean. So that's why I roll with a median there. That's just kind of how it is. Okay. I'm going to stop this video here and I'll do one more video to get through the rest of these notes.